Hello everyone, welcome to my YouTube channel Spot. This is me, Harish Goupale. So basically in today's video, we are going to discuss about grade 2 binary code converter and the RTL design implementation of grade 2 binary code converter. Basically, grade 2 binary code converter is a type of code converter that can translate a gray code into its equivalent binary code, and basically it accepts a gray number of bits as an input and produces a corresponding binary code as output. Basically, a gray code is a reflected binary code where only one bit change at a time between two successive numbers, and it is used to reduce the error during state transition. Now, to change the gray code into the binary, we have to follow few steps. Let's understand that few steps by using an example. Let's say, for example, we have gray code 101010, and if we convert this into the binary, so the output will be 110011. Now how it has converted? By following a few steps. So let's understand this. So what we have to do, first we have to directly assign the MSB bit of gray code to the MSB bit of binary code as it is. Here you can see 1 as it is assigned to the MSB bit of binary code. Okay, now subsequent subsequent bits of binary code is calculated or produced by using an XOR operation between the current bit and the previous bit. So here you can see that is B2 or B2 bit of binary code is calculated by using XOR between G2 and G1. Here you can see 1 or XOR with 0, so output is 1, that is assigned to the output B2. Now B3 is produced by using an XOR between G3 XOR with G2 XOR with G1. So here you can see B3 is equal to G1 XOR with G2 XOR with G3. So 1 XOR 0, obviously 1 XOR 1 is 0. Okay, so you can see B3 is 0. Now B4 is calculated XOR operation with G1 XOR with G2 XOR with G3 XOR with G4. So 1 XOR with 0, obviously output is 0, obviously output is 1. Now again 1 XOR with 1, output is 0. So 0 XOR with 0, output is 0. So here you can see B4 is 0. Now for B5 you can see G1 XOR with G2 XOR with G3 XOR with G4 XOR with G5, and if you do XOR with all these bits, then it produce the output 1. So that is assigned to the B5. Now the B6 again is calculated by using XOR between all the bits. Okay, this is how we have to follow these steps to convert gray into binary code. If you remember, in binary to gray code converter, we the steps which we have followed, that was we have assigned MSB of binary as it is to the MSB of gray code, and the following subsequent bit we have calculated calculated by using XOR gate between current bit and previous bit on only. Okay, now based on this example, we have 4-bit gray to binary code converter. So these are the gray codes. You can see decimal number 0 1 2 3 4. Okay, now let's understand how it has converted. So as per the steps or rules, we have to assign MSB as it is to the MSB for binary code. So 0 is assigned as it is to 0. Now B2 is calculated by using XOR gate between G2 and G3. The output is 0. G1 is calculated XOR between G3, G2 and G1, and B0 is calculated XOR between G3, G2, G1 and G0. So as the all inputs are 0, the output is also 0. Now comes to directly for let's say example for this binary code 0101. So here you can see that 0 MSB is directly assigned to the MSB for binary. So you can see 0 is directly assigned. Now B2 is calculated XOR with G3 and G2. So 0 XOR 1, output is 1. So here you can see output is 1. Now B1 is calculated XOR between G3, G2 and G1. So 0 XOR 1, output is 1. 1 XOR 0, output is 1. So here you can see output of B1 is 1. Okay. Now for B0, output is produced by using XOR gate between G3, G2, G1 and G0. So 0 XOR 1 output is 1, 1 XOR 0 output is 1, 1 XOR 1 output is 0. So here you can see output is 0. Now let's jump for the RTL design implementation of gray to binary code by using system Verilog constructs. Here you can see I have already written an RTL code for the design implementation of gray to binary converter by using system Verilog. So let's go through code. Okay, so my tick time scale is 1ns divided by 1ps. My module name is gray to binary converter. I have used one parameter of bit size 5. Okay, because we are implementing 5 bit of gray to binary converter. Now we have two inputs. One input is 5 bit of gray, and one output is 5 bit of binary. Okay, input name is gray, output name is binary. Now here we have used only assign constructs. So as per the steps, we have to assign MSB of gray as it is to the MSB of binary. So here you can see that I have assigned MSB of gray as it is to the MSB of binary. Now subsequent bit is calculated by using XOR gate between the current bit and the previous bit. So here you can see that bit of gray XOR with third bit of gray is assigned to the third bit of binary as per the truth table whatever we have discussed. Now the fourth bit of gray XOR with third bit of gray XOR with second bit of gray is assigned to the second bit of binary. Similarly for first bit of binary and the zeroth bit of binary. Okay, when I execute this code, then it will give me the schematic. So here you can see the schematic where MSB bit is directly assigned to the binary, and remaining subsequent bit is calculated by using an XOR gates between all the bits. Okay, and to verify this gray to binary code, I have written simple TB code also. So let's go through the code. Here also same tick time scale I have used. My module name is TB for gray to binary code converter. Same parameter also I have used, bit size is equal to 5, and same inputs and output signal, that is 5 bit of binary input, 5 bit of gray, that is the output. Here I have taken an instantiation of gray to binary converter. Okay, and inside the initial begin I have used for loop where I have given value from 0 to 31 as 5 bit means 32 combinations. Okay, for the delay of 10 nanosecond. Okay, when I run this, so it has given me the waveform as I already run this. So let's understand the waveform. Here you can see my input gray bind. Okay, I'll just change this. My gray input is 0, so all binary binary output is 0. Okay, as per the truth table we have discussed. When gray is 1, so binary is also 1. Now let's come to this point. When gray is 6, okay, here you can see my 0, that is MSB bit, is already directly assigned to the output of binary bit. You can see 0. Now for this bit, okay, third bit, XOR between fourth and third bit, that is 0 XOR 1. Here you can see output is 1. Now for this bit, 0 XOR 1, that is 1, 1 XOR 1, that is 0. So here you can see output is 0. Now again for this bit, 0 XOR 1 is 1, 1 XOR 1 is 0, 0 XOR 0, output is 0. Okay, so as per the truth table we got output, we have converted here a gray input into the binary output. Okay, so here I will stop the video. Basically in this video we have discussed about the concept of gray to binary code converter, and also we have discussed RTL design implementation of gray to binary code converter for the 5 bits. Okay, if we change the parameter size for 6, so it will become 6-bit gray to binary code converter. Okay, so if you are watching this video, then please click on like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.